Hi everyone, it's our first video of second semester. Woohoo! I bet you're super stoked. Maybe not. Okay, first of all, just a reminder, check out the log rules on page 282 if you need a reminder. Things like natural log of AB equaling natural log A plus natural log B. All those rules we reviewed earlier in the year, they're going to be back. So today we're looking at derivatives of other log bases. So instead of log based E, the natural log, we have things like log base 7 or log base 5. Now, the smart thing mathematicians do is they take a new problem and turn it into an old problem. So the thing I'm going to do is take log based A of B, so any other base, and I'm going to use my change of base rule, natural log B over natural log A, and change to the natural log. Memory trick, like that base state is low, it stays low. It's a little more convenient if we go natural log A times 1 over natural log A times the natural log of B. So like this log base 7 of secant x, I'll rewrite it as 1 over natural log 7 times natural log of secant x. Because this way it's just 1 over natural log 7. That's just a number. I don't know what number, but it's a number. It's multiplying things, so it's just a vertical dilation essentially. So our derivative then is going to be that 1 over natural log 7 going along for the ride as a vertical dilation, and then times the 1 over secant x. And then, of course, chain rule. So derivative of the inside, derivative of secant x, remember, is secant x tangent x. And just for funsies, we could even clean that up a little bit. So we have y prime equals tangent x over natural log 7. That last step is a little bit bonus, but you know, it's good practice. No big deal. Okay, so looking at this guy, we have log base y equals log base 5 of x squared over sine x. I'm going to do a couple things with this thing. I'm going to, of course, do that change of base to it. So I have y equals 1 over natural log 5 times natural log of x squared over sine x. Now, I could chain rule the crud out of this and have to go 1 over blah, 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 and then quotient rule, and it's just a pain. You know what I can do instead? I can be kind of clever and be all, hey, check me out. I have log rules. So I have this 1 over natural log 5, and then parentheses, be careful with that, because that 1 over natural log 5 is going to hit all of it, 2 natural log x minus natural log sine x. Remember that natural log x squared, you can move that exponent down as a multiplier, and division becomes a subtraction. If you consider PEMDAS, basically logarithms knock everything down one notch on the ladder. And notice the way I wrote that, like multiply becomes add, divide becomes subtract, exponents become multiply. That's my little memory device for remembering all my log rules, because I've known PEMDAS forever. Okay, now one thing to watch for on these is people will often be all, hey, I got all my log rules, look at me go, and they get this far, and then they forget to actually take the derivative of it, and they're then kind of in trouble. So, deriving this guy, I have 1 over natural log 5 parentheses, and then 2 over x minus 1 over sine x, times derivative of the inside, so cosine x. And I know I could clean that up if I felt like it. Why not? I'm feeling like an overachiever today. This is the kind of thing that would show up as a multiple choice question, so you would definitely need to be able to clean it up. So getting it to the 2 over x minus cosine x over sine x is cotangent x. Hopefully you know those rules too. So there we have that. Okay. So that's like thing number 1 of the week. Thing number 2 is looking at the derivatives and integrals of things like b to the x. We, of course, have done the derivative of b to the x before, and I know you know that the derivative of b to the x is b to the x natural log b. So if we're going to go in reverse of that, instead of multiplying by natural log b, we'll just divide by it. So we have b to the x over natural log b. And plus c, because remember we always have our constant on those indefinite integrals. So Because remember, you can check your answer on that guy, and if you checked your answer by deriving it, you would have those natural log b's cancel. Okay, while we're at it, just a friendly reminder, the derivative of e to the x we know is e to the x. And of course, if that x was another function, chain rule. And then going in reverse, it's kind of like undoing the chain rule, remember? So like that u, the exponent, is a function on the inside, and then that du is the derivative of the inside. So you're looking for both of those things, and hopefully it all works out. And then if it does, you get e to the u plus c for the antiderivative on e to the u du. So those are the things you're going to be using. As ever, you're remembering to use the chain rule, derivative of the outside while keeping the inside the same, times derivative of the inside. Remember that guy? Yeah, I know you did. So today's assignment is going to feel kind of reviewy, because really it's just one new bit of that log-based other things and using those, you know, that change of base rule. So you can take it from there. The purpose of this week is to get you faster and more accurate at doing these rather routine problems. So you're going to do a ton of them, but you're going to get faster and more accurate. At least that's the goal.